Good morning, students. It's 8th of April, and today we are going to start our lesson number 4, chapter number 8. I want you all to open your books, page 460. On this page, we have the topic What happens to larger stars? The stars that start off with great amounts of hydrogen end their cycle differently. Means the stars that start off with greater amounts of hydrogen, they end their cycle differently. After they become red giants, the temperature of the core of these stars increases to about 600 million or 600 million degrees Celsius or 1 billion 80 million degree Fahrenheit. The temperature of after they become the red giants, the temperature of these cores they increase to this much amount. At this temperature, their atoms combine to form atoms of iron. Means when the temperature raises this much, their atoms they combine to form atoms of iron. Their atoms they combine to form atoms of iron. Eventually, the iron core produces more energy than gravity that can hold together, and the star explodes. Now, then what happens? They produce more energy. The energy produced is more than the gravity which can hold them. Now here the gravity is less and the energy produces more. So when this happens, the gravity is less. When the gravity is less and the energy is more, so what happens? The star explodes. The star it then explodes. The exploding star is called a supernova. This is the definition of supernova. The exploding star is called a supernova. Supernovas shine brightly for days or weeks, then they fade away. Now the supernovas they bright for few days or for few weeks, and after that they fade away. A supernova will form a new nebula. Then the supernova will be converted. It will form a nebula. Nebula is a giant cloud of dust and gases. If a star is very massive, it may end its cycle as a black hole. Means if the star is very big, it's very massive, so it can end as a black hole. Now, what's a black hole? A black hole is an object that is so dense as has much powerful gravity that nothing can escape from it, not even the light. Means what is a black hole? A black hole it's an object and it's so dense, it's very dense. Gravity is much higher. The gravity is so high, it's much dense, and it has very strong gravity. It has such powerful gravity that nothing can escape from it. Means it can attract anything. The gravity is more, and even the light, it can attract the light also. Nothing can escape from the black hole. Stars are characterized by size, color, and temperature. We can categorize the star by we can categorize the star on the basis of their size, color, and temperature. The Sun is a medium-sized yellow star whose surface temperature is about 6,000 degrees Celsius. Means our sun, the sun of our sun, it is medium-sized yellow star. If we compare it with the stars, so our sun is it's just medium size, and the temperature is nearly 6,000 degrees Celsius or 11,000 Fahrenheit. Giant stars have diameters that are 10 to 100 times that of the sun. The giant stars they are much bigger. They are 10 to 100 times larger than the sun. Supergiants may have diameters that are 1,000 times that of the sun. Now the supergiants they have the diameters more than 10 times of the sun. Now neutron stars are the smallest stars. The neutron stars they are the smallest one. Betelgeuse, this is the Betelgeuse. It is red color and its temperature is nearly 3,000 degrees Celsius. Aldebaran, It is red orangish. Its temperature is 5,000 degrees Celsius. Our sun is yellow. It's 6,000 degrees Celsius. Altair, it's white. Its temperature is 10,000 degrees Celsius. Spica, it's blue and its temperature is nearly 35,000 degrees Celsius. On the next page, 461, we learn more about the stars. Planets around distant stars are too dim, small, and far away to be seen even through a telescope. The planets that are around the distant star, the stars that are very far, the planets around them, they are very dim, they are very small, and of course, they are very far. And they are so much far that even with the help of telescope, we cannot see them. They are very, very far. How are these planets discovered? Now, the question is, if they are very, very far, so how were they discovered? Remember that gravity causes all objects to pull on all other objects. Yes. When scientists observe a star whose motion is not smooth, they infer that another source of gravity is present. Now, when scientists were discovering about the stars, and they found that if the motion of the star is not smooth, if the motion of the star is not smooth, so it means that there is some other gravity present over there. So by this, they got to know about other planets. By measuring the motion of the star, astronomers can calculate the mass and distance from the star of the possible planet. Now, when the scientists, by measuring the motion of the star, when the scientists were measuring the direction of the motion of the star, from the motion of the star, they can calculate that what's the mass of the planet around them and how much it is far from that star. Means what's the distance between the star and the planet. Using such methods, astronomers have discovered what may be more than 160 planets beyond our solar system. By calculating this method, scientists have discovered nearly 160 planets, that are beyond our solar system. Most of these planets are probably giant gases. Means these 160 planets which the scientists have discovered, most of them are gas giants. However, scientists have reported finding what may be a rocky planet orbiting a red dwarf. Now, the scientists have also discovered that there is a rocky planet that is orbiting a red dwarf. And again, it's very, very far from here. Now, scientists calculated that the planet was 5 times more massive than Earth. The planet which the scientists discovered, it is the rocky planet. It is 5 times more massive than Earth. It's 5 times more heavier, 5 times more massive than Earth, and 3 times farther from its star than Earth is from the sun. And the distance between the planet and its star is 3 times more than the distance between sun and Earth. Temperatures on its surface were thought to be about minus 364 degree Fahrenheit. The temperature over there at that planet, it is about minus 364 degree Fahrenheit or minus 220 degree Celsius. Astronomers found this planet by analyzing data of the star's brightness for changes that indicated that a planet passed in front of the star. Now, how the scientists discovered this planet? The astronomers found a change in the star's brightness. Astronomers found a change in the brightness of the star, which means that some planet is moving around it. So that's why, because of that planet, there is some changes in the star's brightness. And this method is called gravitational microlensing. This method is called gravitational microlensing. Students, I'll stop the class over here. From page number 462, we will continue tomorrow, inshallah. Till then, bye. Thank you.